27. All right, I think we'll go ahead and get started. I show right at 4 o'clock, or a minute past, and we have this countdown timer that says 59 minutes left, so I don't know what's going to happen at 59 minutes. We just might all disappear. I don't know. So we'll go ahead and get started. Thanks for being here today. I am the last session of the day for the 2-day conference, 3-day conference if you include the workshops. So I really appreciate you spending your Friday afternoon here. I know we're probably all burned out of the virtual thing, but hopefully we can talk about some indexes. I'm John Morehouse. My email address is on the screen, john@dcac.com. And you can email me, and the next slide will have a little bit more contact information. But if you have questions about the presentation, or you have questions about SQL Server in general, you're stuck at work, you don't know what the answer might be or who to turn to, feel free to drop me a note. And if I can help solve the problem, I'm more than happy to do so. And my clicker doesn't want to work again. Oh, where am I? All right, here we go. So as I said, my name is John Morehouse. I'm a consultant. I work for a small company called Denny Cherry & Associates. My Twitter handle is on the screen as well. And just to quantify that, SQL R Us, not SQL Russ. So think Toys R Us, everything toys. I touch just about every facet of SQL Server. Don't ask me to build Power BI cubes or charts or graphs or anything like that. That's not my forte. I deal more with the infrastructure and SQL Server under the hood. I do blog at SQLRUs.com. Usually I blog about the internals of SQL Server. I literally will reverse engineer hexadecimal at 10:30 on a Saturday or Friday night because I don't have a social life. I speak quite a bit. Twitter's about the only social media that I use. I do have Facebook, but I kind of quit Facebook a couple years ago. I am on LinkedIn, so feel free to connect with me on LinkedIn if you so desire. I am a Microsoft MVP in data platform and have been for a couple of years, so I'm really honored to be a part of that group. I help run the local Louisville SQL Server user group here in town. If you are into SQL and want to start learning more, we do have a local user group that meets usually once a month on Meetup. We now obviously switched to virtual. Excuse me. And I help organize a SQL Saturday, which if you're not familiar with what a SQL Saturday is, we actually host about 8 or 9 hours of free training related to the Microsoft SQL Server platform, but we also include other data platforms as well when they want to. So we've had Amazon in, we've had Google, we've had Snowflake, we've had a number of different things, but usually we pick up Saturday and we actually fly in speakers. When I say we fly in, they actually pay for their own flight. We don't have that kind of money, but we bring speakers in and try to give back to the community. It's all free. The only thing that costs you is $15. This year we're postponing it obviously for COVID, but you can go out to SQLSaturday.com. And if you're not in the Louisville area, there's usually SQL Saturdays around just about every weekend when we're back doing physical meetings. So if you want to expand your knowledge and learn more about SQL, definitely check out SQLSaturday.com. A quick blurb about the company I work for. We are a small shop. There's 6 of us, technical folks. We're spread out pretty much over the United States. So I think we're in all 4 time zones for the most part. So, but if you have SQL Server problems, need help, we're happy to come talk to you. If we're not a good fit, we can recommend somebody else that might be a better fit for you, or we'd be happy to try to help you. We are community focused. So like I said, if you want to drop me an email and say, hey, I'm having this problem. If I don't know the answer, one of my colleagues might know, or I can point you in the right direction. So we like to help. So these events can't run without sponsors. I hope that sometime during the conference, you snuck into the sponsor booth area, had some engagements with the sponsors that help put these things on. It takes money and takes time. If you know Chad has been working tirelessly to get this thing rolling in virtual, and I've been really impressed with the platforms that we're using and the conference overall. So take a second, reach out to Chad, say thanks, reach out to these sponsors, say thanks, listen to their spiel. They might have a solution for you for one of your problems. So we will, Richard asked if our Louisville SQL Saturday, I assume, will go virtual. We are not going to go virtual at this point in time. We actually paid some money to a venue here in town, and if we cancel it, we lose some money. So we're trying to just wait it out and see what happens with the pandemic. So up next, so here's a brief agenda. I will forewarn you that I am known to take a 60-minute presentation and turn it into 3 hours. So I won't plan on keeping you for 3 hours. But we're going to talk about the purpose of indexes, the types of indexes that we're going to cover today, indexes under the hood with SQL Server. I've got some demos on how to fix a couple of things that we see quite often in client environments. And you can get some really quick wins with putting on the right indexes or what to look for. And then we'll have a Q&A. I like as I mentioned with Christopher, I like questions and stories. So feel free to chime in the chat. If you get a camera or want to go on camera or on audio, totally fine. Feel free to interrupt me, not a problem at all. So indexes. Indexes are an object that you put on a table to help increase query performance. Really, it helps you read data. And this is not specific to SQL Server. Indexes can be put on other database projects or platforms, Oracle, MySQL, et cetera, et cetera. They help you query things faster. Now, most of the performance problems that we run into, we solve literally by putting correct indexes in place. We don't do anything magical. We don't, wave a magic wand and things become suddenly better. We just know when looking on how queries might perform, we can identify where indexes might be missing. Now, SQL Server and some of the other platforms have some built-in intelligence to help suggest where an index might help, but most performance issues can be resolved with proper indexing. That's why indexes are magic. And so you can see our little unicorn in the lower right-hand corner. Now, the other problem that you can run into, though, is it's really a balancing act. You have to find that right balance of having the right indexes in place, but not too many. If you've ever worked in an organization where, and where I see this happening is where you have a bigger shop and you have a bunch of people that are developing SQL Server databases and or SQL Server queries, and they throw on indexes that will benefit their query. However, what they don't know is that their colleague sitting 2 cubes down also put in a similar index that solved their problem, but you can literally combine those 2 indexes into one. And so you can have too many indexes, and too much of a good thing is a bad thing. I actually had a client in a former consulting shop, where the indexes were twice the size of the physical table. The index space was like 200 gigs, really big indexes, and the table space was only like 100 gigs. And that was a problem. Ironically, they wouldn't let me fix it, but so too much things can be bad and they can consume extra spaces. Really bad design. Edward asks, is there a lot, was those indexes lots of includes? And really the real answer was the indexes were really wide in terms of keys and really bad table design. And it was one of those shops that they said, oh, it's fine. But that's another story. So indexes help improve performance. We can solve most performance problems, I bet, with indexing. So first thing as a consultant I'm going to look at is if you tell me you have query performance issues, I'm going to look at indexes, okay? So let's talk about some types of indexes in SQL Server. So the first one is going to be a clustered index. And just to note, the ones that I have asterisks are the ones that we're going to talk about today. There's a number of index types within SQL Server. I could probably spend 8 hours talking about just indexes within SQL Server. So clustered index, this is going to be the physical table itself. This is an index where you define a clustering key, and that clustering key is going to define the physical ordering of your data. Quite often you will see the clustered index being ordered by like customer ID, or there's some numeric increasing value that will identify that row within the table. You can only have one clustered index on a SQL Server table, but on top of that, you can have what's called a non-clustered index. So a non-clustered index is not going to be physically sorted from the table, okay? You can define number of non-clustered indexes, and I have a slide coming up that will depict how many you can have. And really the non-clustered is a way to point back to the clustered index the data you need for your query. So when your query comes in and says, hey, I need this data from this table, if there's a non-clustered index, it'll go read the physical structure of that non-clustered index, and that non-clustered index has pointers back to the clustered index. So it'll read the key, find the include, and read it back. Okay. There's a hash index. There is a memory optimized non-clustered index. There's a unique index. There's a Columnstore index. And I bring up Columnstore because Columnstore is newer. 2016, I think, is when it got introduced. 2016, 2012, somewhere around there. 2014, excuse me. And Columnstore has made a bigger stride. It came out originally for analytical processing as a way to speed up analytical and aggregate queries. But we're actually seeing more Columnstore indexes coming into play with OLTP type environments where you're doing online transactional processing. And they're coming into play where it makes sense, where you're not doing a ton of updating of data. You're just inserting new rows. And then column stores and stuff might be a good solution for you. I do have a couple slides about structure on how that works. Hopefully we can get there in time. So we'll talk about Columnstore a little bit more in depth. So I'm going to kind of keep on just for time. Now with non-clustered indexes, we can also do includes. I kind of mentioned it a little bit earlier on the previous slide, where a query with if an index has an include column, a query can utilize that to go back to the clustered index to find it. Okay. You can also have a filtered index. So I can actually specify an index in SQL Server to say, give me an index where customer ID is between the values of 1 and 10. And so that makes that index a lot smaller. And so the query can utilize that smaller index in a more efficient manner. So we can filter on the data that is contained within the index itself. If you've ever messed around with spatial data within SQL Server, so SQL Server actually has native spatial functions that you can do spatial manipulations of the data to get spatial information. It's actually, ironically, it's actually calling CLR functions underneath the hood, but we can put indexes on that spatial data to make those queries faster. If you have XML, if you put XML into your database, good and bad, you can put indexes on top of that XML to make it run faster. Okay, so that is available to you. If you have full text, you can use full text. Full text is where you do a fuzzy search on a value and we need to find it. And so you can define that within SQL Server. Okay, so let's take a look real quick. And two of the ones I mentioned, the clustered and the non-clustered. If we have a clustered index on a table, then it's not a heap. So a heap and a clustered index are binary values. It's a 1 and a 0. It's either a heap or it's a clustered index. There are no, it's a heap and a clustered, or it's a heap and nothing else. Well, you can have a heap and nothing else, but a heap is the table itself. There is no clustered index on top of it. You can have a heap with non-clustered indexes, and a heap is always going to be index ID of 0. So if we go spelunking through the internal tables of SQL Server and look at the various index properties and the statistics, the index ID will always be 0. If we put a clustered index on top of that, and remember the clustered index is going to sort the data physically by whatever that ID value we supply, the customer ID or the ID, we sort that table physically. It is the data itself at that point in time. Okay, so as soon as when we put the clustered index on it, it is the table. You can only have one, as I mentioned, physically sorts the data, and that index ID will always be 1. So if you are looking through your tables or your indexes in your SQL databases and you start seeing these index IDs, if you see an index ID of 0, you know right away you do not have a clustered index. If you see index ID of 1, you automatically know that you have a clustered index on top of that table. And the non-clustered index are pointers back to the clustered index, right? So we can filter them. We can do include columns. This is where you can put 999 non-clustered indexes on top of a table in SQL Server. This is not a goal. I have been in organizations where they want to attempt to reach that goal. I have never seen that. That's a demo that I have actually wanted to build, is to put 99 999 non-clustered indexes on top of a SQL table and see what happens. Remember when I said that too much of a good thing is a bad thing? That would be it. So that's not a goal, but you do have that flexibility. If for some strange reason you really needed to, you could put 999 indexes per table. Okay, so let's look. So that's the index, and non-clustered and clustered indexes follow a structure called the B tree. And it really looks like this. And this image was borrowed from Microsoft Docs. But this is what the index looks like from a physical structure. And in my mind, when I first read B tree, this is what I thought of it. And this is basically the way it works. Your top level is your root page. And so it would be the root of the tree. Your immediate level pages here in the middle represent the middle of the tree and your branches. And then the leaf level, or where the data is stored, if it's a clustered index, then it's the actual data. If it's a non-clustered index, it's actually the data that points back to the table, or the clustered index is the actual leaf of the branch. So now that you've seen this, you probably won't ever unsee this. I actually showed this slide deck to a colleague of mine here in town, and he's like, yeah, I can't ever unsee that. He never made that correlation. So now he always is going to picture an index like an upside down tree. Okay. So this is the physical representation of a clustered index. We can see at the very top, we've got the root node. Again, it's the root side of the tree. And then we can have multiple intermediate levels, so multiple branches. And then we have leaf levels. And so that is where the data is actually stored. It's stored on those individual pages. Okay. And each page is 8K. So we know for sure that each page is 8K. We know how many pages are in an index. We can actually calculate the size of that index if we wanted to. Remember when I told you I reverse engineer hexadecimal on a Friday night? Yeah, this is what I do for fun. A non-clustered index, as I said, is a pointer. We don't have intermediate levels, so we still have a root, but the middle is just additional leaf, and then we have data pages. Okay, and so the non-clustered index can filter its way down to the bottom to say, okay, where does this data live? It has a pointer back to the clustered index, and it goes and fetches that data. So it's a little bit slightly different structure from non-clustered to clustered, but that's the physical way that it works. We can actually see this level being broken out here in this slide. We can see that, and this is a DMV, which is a dynamic management view within SQL Server. We can write this query and say the database ID of wide world importers. We are looking for a specific index, or in this case, I was looking for a specific index to have a value. But we can see that the index level of 3, the very bottom row, is actually our root. So that would be our root level of the tree. Index level of 2 would be the intermediate. And then we have another intermediate level of 1. And then we have 0, which is going to be the leaf level of the page. And we can see that we know how many records are on each level and how many pages are on each level. So I know that the first level, which is level 3, is going to be 8K because there's only one page, and so forth. I can actually do math against that if I really wanted to figure out other information. Okay, but physically we can actually see this structure within SQL Server, which is kind of cool. So how does this really work? So if we understand the structure in terms of how the B tree works, what really happens? So let's go Pinko. I'm going to show my age. I don't know if they still do it, but Price is Right has this game called Pinko, and you would put a puck on top, like where the word says Pinko, flat, and then you would release it, and the puck would basically Pinko and basically shimmy its way down that Pinko board into a slot, and the slot at the bottom dictated how much money you won. I was always fascinated with the game Pinko, but now, and you probably won't be able to unsee this either, but now with we understand how the structure of the indexes work. It really kind of works like Pinko, only it's a little bit more controlled. Okay, so the first thing we do is we evaluate the root node, the top level, right? That one page that says, and in that page are ranges of the value we're looking for. So we're going to evaluate that top level to say, where does this live? once it figures out which the next path it needs to go to get the intermediate level, it goes and navigates that intermediate level to find that next range. And then it basically rinses and repeats until it finds the leaf level, and then it reaches the leaf level, and then it returns the data back to your query. Now, SQL Server does all this milliseconds. Well, assuming that your queries are written correctly and your table design is good and you've got good infrastructure behind it, it should be in milliseconds. So SQL Server is very quick about figuring out how to do all this and get down to that leaf level so it can return the data. But it's like Pinko. So let's look at an example. So let's say I have this query, select name from dbo.people where ID is 15. So I'm looking for an ID value that is equivalent to 15. So let's Pinko. So we have the B tree, right? So it's an upside down tree. So the first thing that's going to do is look at that top root page and say, show me which page does the ID value of 15 live on? And we have two options, 1 or 728. And so it'll actually say, okay, I know that it's on the page that where it's less than 728, but greater than 1. So it's going to navigate its way down to the intermediate level and ask the same question: where does the record live where the ID equals 15? Now in the intermediate level, it has a little bit more granular range to pick from, because the values have kind of split out along its way. Now, after asking the intermediate level, it can say, okay, we know where on the leaf level it resides. And so we are going to return the value of Kimberly Tripp. So this is kind of like Pinko, just a little bit more controlled, but it's going to Pinko its way down that tree to figure out where it lives on that data page and then return that data. Okay. So now we kind of have an idea as in terms of the structure of the index, kind of how it works. It Pinkos its way down. What are some considerations that you need for indexing? So with SQL Server, and this is just SQL Server, I'm not an Oracle person or MySQL or any other database platform. So I don't have any knowledge around that. So in my opinion, when you put a cluster key on your database and you want to create that clustered index, your clustering key should be sequential and should be forever increasing. If you use certain things like GUIDs and whatnot, you run into things what are called page splits, and those are expensive in SQL Server and can introduce performance issues. I'm not really going to talk about that here, but having those keys sequential inserts data at the bottom of the page and makes your index designs better. Your index keys, the keys themselves that define the index, should be narrow as possible. You can put, I want to say, up to 16 columns in the key itself. I've never seen that done, and that too is not a goal. Try to get your index keys to be as narrow as possible. If you're going to have multiple keys, which is called a composite key, make the most selective column be the far left or the first value in that key. And you want your keys to be as selective as possible. The searchability of that value, the search and return ability of that value is very important. So if you can find a selective key, that's better. The most selective key needs to be in the far left, though, if you're doing a composite key. And again, composite key is just two values together. If you're using non-clustered indexes, include columns make a world of difference. We actually have a value or a performance thing that we run into called a key lookup, and we can actually fix it by changing some non-clustered indexes. And that's one of the demos I have, is to actually have those the key lookups to be fixed. And then finally, don't over-index. Again, that's a balancing act between finding an index or creating an index that fits your query needs and or potentially query performance needs without putting too many indexes on place. And this is where, again, if you have a large organization, you've got multiple people creating tables, creating indexes for their queries, communication is key, especially if you don't have a DBA in the shop. I am a DBA for several of my clients. I am their DBA. And so it's part of my job to make sure that we all talk and figure out the right value and the right combination of indexes so that we don't over-index, but we still can get performance gains out of fixing the right indexes. So how do we find index problems? So that's part of the problem that we need to figure out how to find. So the first thing that we're going to look at is execution plans. When SQL Server gets a query, it actually does some binding and some parsing, and it generates what's called an execution plan. That execution plan is XML in nature, and I'll show you kind of what some of them look like here in a demo if you're not familiar with them. But the execution plan is then given to the storage engine of SQL Server, and the storage engine says, okay, give me that roadmap. I'm going to go fetch the data. And then the storage engine will take that roadmap, go query all the indexes it needs, all the right pages on disk, find the data you need, and then come back and give it back to you. The execution plan is probably the foremost method to find where index problems are occurring. Now, you can take that a step further. In 2016 and higher, if you're in SQL Server 2016 or higher, they have a concept called Query Store. And Query Store utilizes the power of the execution plans to give you metrics about those plans. So we can define, let me take that back. We can locate queries that are saying, show me the top resource consuming queries of my database using Query Store. And I can show it to you here in the demo. The Query Store will display the execution plan, but it's good to have additional metrics about that execution plan. If you're in Azure SQL database, you can actually find where queries might be having issues by using the Azure portal. You can actually go into Query Performance Insights and define and see where you might have slowly performing queries, and those would be my immediate things to go look at. You can also do automatic tuning within Azure. You can actually allow Azure to create and drop indexes on your SQL database because it's got machine learning behind the scenes actually doing analysis on your indexing and on your queries. So you can actually allow Azure to fix some of your performance problems immediately. I would test that. Don't go put that in production and say, oh, John said to do this. Test it first. There's a bunch of people in the SQL community that offer queries that can help you go find where indexes might be missing. SQL Server actually has dynamic management views that will gladly tell you where indexes are missing, and you can go add those indexes. That's not carte blanche to go add every single missing index that SQL Server provides. We really need to find a happy medium about adding missing indexes and then reevaluating. Excuse me. That's another thing about indexes with SQL Server is it's not a Ronco set and forget it. If you remember those commercials about setting and forgetting things with these fancy devices that Ronco always made. Index maintenance, index performance, query performance is always an ongoing thing. So make sure if you're going to put an index in place, come back to it, the following week, the following day, some iteration later to make sure that query and that index still makes sense. As we load more data, index needs change, and you can reach a point where you've loaded so much data beyond when you put that index in place. Maybe that index is causing problems and not really providing you much value. So don't think that you can just slap on indexes, call it good, and never have to come back. As a consultant, re-evaluating the value and the utilization of indexes is pretty much one of my daily jobs. I go touch all my clients and check out all their SQL servers and make sure that indexes are doing what they're supposed to do. If they don't, then we reevaluate what that index is supposed to do. Another thing that I look for is we can use those internal tables and views of SQL Server is to really see what read-write ratio I'm getting out of that index. As I said at the beginning, the purpose of the index is to help increase your performance when reading data. It's about finding data and reading data. So if I have an index and I don't ever read from it, but all I do is write to it, then I actually have a performance issue right there, because that index isn't causing me that index is not bringing me any return value because I'm not using it to read. All I'm doing is wasting IO because I'm writing to that index. So I have a query I'll show you, and we actually will run a workload, and I'll show you the ratio of the read writes changing. And so I will look at that to figure out whether or not that index makes sense. If your read write ratio is 0, meaning that you're always writing, not reading, then maybe that index needs to go away. If it's always 100, I always read from it, I don't ever update it, then that might be okay. So that's what I use to find these indexes. Things to look for. So when we start looking for index problems, I'm going to use the execution plan almost all the time. That's my first go-to, is to use the execution plan for to find the index problem. Things I'm going to look for is a key lookup or a RID lookup. And this is, I've kind of mentioned it before, a key lookup. This is what it looks like in an execution plan. And so what this is doing is we can see that we've got two operators. The top one is an index seek for the order lines table, and the bottom one is a key lookup for the same table. And so what's happening is that the top index, the index seek, doesn't have all the columns available to satisfy the needs of the query. And so what has to happen is the query, the engine, will read that order lines, IX, sales, order lines, allocated index. It needs certain columns. It can't find it. And so for every row, it has to go back to the clustered index and do what's called a key lookup. The key lookup also designates that I have a clustered index on it because it's looking for a key. It's looking for a clustering key. If I had a heap, that would say a bookmark or a row ID lookup. That is expensive, especially if you're doing large volume data queries. And if you don't have substantial hardware behind SQL Server, fast network, fast disk, or anything like that, a key lookup can be horribly detrimental to the performance. You'll notice that there's a cost associated with this. See if I can zoom in. I can. Oh, did that change you? Oh, it didn't. Oh, it didn't change your screen though. So you can see that the cost, if you look below the key lookup where it says PK _ sales _ order lines, you see the cost is 100%. So the cost of this query to SQL Server, 100% of it is actually doing that work of going from the non-clustered index, going back row by row to the clustered index, and then bringing that data back. And we can see that if we actually were to hover over that, the tooltip would show us that we have a number of executions. And so that number of executions was 3,396. So it made 3,396 trips from the non-clustered index all the way back down to the clustered index to get that value, the values, right? And so that is I/O. I/O is expensive. If we can reduce I/O, the performance of your queries get better, okay? We fix it by readjusting the non-clustered index to include the columns that it's missing. We can find the columns that it's missing by hovering over the key lookup. And then if we look in the middle down, I've got it highlighted, the output list. Those are the columns that it's looking for when it goes back to that clustered index. So we can just add those columns as include columns to the non-clustered index. And then there, the query doesn't have to go back to the clustered index, and we have solved this performance problem. And we no longer have that detriment of having to do 3,396 trips back and forth. We can just do one trip to the index and get what we need. The other thing I look for in my clicker, index scans that have a predicate. So if I have a query that has a predicate, and the predicate is the where clause, so if it has a predicate and I'm still getting index scans, then I'm not utilizing the indexes correctly. If you have a query that does not have a where clause, you're going to scan the entire index, whether you like it or not, because you haven't told SQL Server to look for a specific value. So if I have a where clause in my query and I still get a scan, like this one, I'm going to go look at that plan and then figure out what do I need to index on in order to get away from a scan, because if I scan the whole table. What I really want is a seek, and the seek would allow me to go directly to that value I'm looking for and return it to my query. A seek will almost always be better than a scan. There are instances where SQL Server will say, nope, a scan is going to be faster, and so I'm going to scan the table. That usually occurs when the table is smaller in size. But if you have very large tables, a seek will almost always outperform a scan. So this example, I'm going to go back and say, okay, I'm searching by quantity. I don't have an index on quantity, so I'm going to need to add that column. We can see how many rows are red. Again, if we hover over that index scan, we can see that I've read 773,668 rows, and that's the number of rows in that index. So I've read all that data when I really don't have to, and that gets expensive. So index scans can get expensive. Now, in this case, I did it parallel. It went parallel, and I actually did it in 2 different batches. And so we can verify that, yep, we are reading the entire index. And that, again, that gets expensive. And so we really don't want to do that. These things we want to go fix. So these are the top 2 things that I go look at, is for a key lookup as well as an index scan. If there's an index scan, then I want to get rid of it. Key lookup, I want to get rid of it. Those 2 are probably the quickest ways to get the biggest performance value out of making index changes. So quick customer story, true story. We have a client, they're in Azure, but the index methodologies is the same. We apply the same logic, and we fix things in the same manner. Can you see when the index was added? They were having horrible performance problems. I can't zoom in on the slide, but it was at 80%. And we did some analysis on some of their queries. They're like, hey, this particular query was having problems. Can we do something with it? And so myself and one of my colleagues, we took those queries and did some testing on it. And over the course of the period, we said, yeah, here are the indexes that we need to add to fix this problem. And so you can kind of see exactly what kind of value. And we're not talking days and days worth of work. We're talking about, we evaluated some of the execution plans, looked at the queries and said, yeah, you're missing some indexes here. We need to tweak these indexes to have the include columns. And we brought their CPU utilization down from a steady, like it was at 80% all the time, down to, on average, 15% basically. We split a line down the middle. So that's a really big gain. Go from above 80 down to 15. And they now stay roughly about that value, about 15% is where they're at on an average day. I think their CPU on average, I think, is less than that. I think it's 7 right now. All from adding indexes. We didn't change their infrastructure. We didn't change anything else. We just added indexes. So indexes are magical. So let's talk about, we talked about non-clustered and clustered. Let's talk about Columnstore real quick and see if we can get through this. I think I've got time. I got about 22 minutes. Okay, cool. So Columnstore, as I told you, is a different way of, and from my understanding, Columnstore has kind of been around a little bit longer in terms of other platforms. But for SQL Server, it's been around for a couple iterations in terms of the version of SQL. But Columnstore has really kind of changed the way that we look at indexing for analytical processing. And some of the benefits of Columnstore is you get highly compressed indexes. So SQL Server loves compression, because if we compress the data on the individual page within the index, then we can get more data into memory. And with SQL Server, memory is king. Everything works in memory for SQL Server. You don't want reads or writes to disk. You want it to memory first, and then let it flush down. So memory is very important, and the more data we can fit into memory, the better SQL will perform. So with Columnstore, you get really great compression out of your data, and so your queries can run faster because there's more data in memory. And so you can actually get an order of magnitude better for performance, and it's primarily used for analytical. As I mentioned, if you've got a data warehouse or you've got a lot of analytical queries, if you haven't been looking at Columnstore, Columnstore can help solve some of your query problems when you're doing those analytical aggregate queries against your data warehouse data. It also works well with large non-volatile OLTP data sets. And this is where we're seeing a slight trend change, in that when people are getting more and more transactional data, but they're large volumes. A good example is we have a client that they do battery monitoring for like smoke detectors and other devices in commercial facilities. But their devices send back large amounts of volume of data about their batteries and the device itself. So it's analytical, but we still put Columnstore on top of that because of all the value we get. The data is just incoming. We're just streaming it in. We're not changing the data. And so we can use Columnstore to help facilitate some better performance because that data is not changing. And literally the data is actually stored physically in a column. And so it actually takes the value of the column and actually stores that value in a column. And so that column store kind of makes sense. So this is the physical structure of what it looks like. And so we can see that we are taking each value in column A, and then it shifts it or pivots it into a physical column. So for every row, every column A is now in a column by itself. Column B for every row is in a column by itself. Column C, the third column, is now in a column by itself. And so SQL Server can say, hey, just give me the values or give me the columns that you are looking for. And so it can very quickly correlate all those values and put it back out to you. So it improves the search performance of the query because it's in columnar format. Let's see. Ed says, I have a large 32 million row notes table that keeps growing. We never edit the note once. I would say yes, that could be. Is that table a candidate for Columnstore? I would say yes. Now, again, I'm going to tell you to go test it just to make sure. But Columnstore, you're going to get better compression. But yes, if you're never touching it, then it's non-volatile. I would go tell you to go look at Columnstore to see if you, especially if you have performance problems, that might help fix some of your problem. So go take a look at that, and feel free to drop me a note back and let me know because I'd be curious to see how that goes. And with that Columnstore, we can then therefore reduce I/O, and so we like reducing I/O because then our queries are faster, right? And we're not putting as much pressure on the SQL Server or the infrastructure. So anything we can do to reduce I/O or CPU, we like. So we can maybe put Columnstore in place to go fix things. And this is basically how it works. So Columnstore will take, and Ed, I'm going to use your example. We have a 32 million row table. So the Columnstore process is going to group things, put the rows in columnar groups of 102,000 up to 1 million rows. And then it morphs the rows into what are called column segments. And then anything that doesn't fit in that 102,000 to 1 million row range is remaining into what's called a delta group. And so it's got this little remnants of the data hanging off down below that as data gets added, it'll get added to that delta group. And then once the delta group is big enough, it'll put it back into the columnar format. And a group of delta groups is called the delta store. So you have multiple delta groups that can have then form the delta store. And there's actually a process called the tuple mover, I think it's tuple mover, that will actually move the data from the delta store into the columnar store behind the scenes. And there's actually, if you follow Stack Overflow on Twitter or whatnot, they actually ran into a problem with the tuple mover, and then it actually caused a performance issue because they had certain things set. Normally, that's an edge case, but there's a process that will move that and shuffle that data around as you add data to that column store. Okay, so let's step through this real quick. Oh, my clicker does not want to work. That's really weird. Okay. All right. So here we have Ed's 32 million row table. And so we have on the far left, we have the rows that we want to load. I know the example says 2.1 million, but it's going to take the 2.1 million row table and it's going to divide that out. And so we're going to have two row groups of 1,048,576 rows. And then we can see that we have the extra segments down below are the delta store or the delta group hanging off the bottom down there. And then we take the row groups and we put them into the column segments. So we have six pillars of 1 million rows per group for a total of 12 column segments. Now the delta group at the bottom is the combination of all the extra rows that are left over from the row groups. So we can have one delta store. So as you add new data to your column store, it'll be added to the delta store, and then the tuple mover will come along behind the scenes and actually move that data into that column store format as it reaches the volumes that it needs to actually move that data. Okay, so column store could be a great solution if you have a large, even transactional processing table to help get better performance. So I definitely go look at Columnstore. Again, I'm seeing it more and more in online online transactional processing environments because it makes sense, especially for like Ed's situation where you don't ever touch that data. You just put it there. That might be a good choice for you. So definitely go look. Okay, demo time. Do we have any other questions? I feel like I'm rushing a little bit, but I've got like 15 minutes left. I don't see any other questions. So in the demo, I'll show you how to fix a key lookup and walk through that. I'll show you how to fix an index scan. And then I've got a query, and I don't know if I can upload scripts or anything like that to somewhere. If you want the slide deck or my scripts or my demos, drop me an email, send me a tweet. I'm more than happy to share. You can go use it as you see fit. Should not break anything. If you use it in production and it burns down production, I didn't do it. So let's go look. Okay. Now, hopefully you see, yes, cool, excellent. So this is Management Studio. And so I have a SQL Server 2019 Developer Edition of SQL Server running on my local laptop here. And I'm using a sample database. If you're not familiar with the sample databases, Microsoft offers free data. And so you can, if you Google Microsoft SQL sample databases, there's various kinds of sample databases. You can get a data warehouse, you can get transactional processing. Great way to play around with data and make things work. And so that's what I'm using. I'm using a sample database called AdventureWorks 2017 because I made it work. So I'm going to do a little bit of cleanup. I'm actually going to drop an index that's probably there for my testing. And then I'm going to put a new index in it. I'm going to create a new index because I need it to behave in a certain fashion. So I'm going to click execute. And so we can see that both commands happened. So in order to get to an execution plan, for those that are not familiar, it's this button right here. So if you hover over it, it'll show you the actual execution plan. So when you run the query, it'll bring back what that execution plan was. You can also get an estimated execution plan, and that's that button right there if I turn that on. And the difference is that if I do an estimated, it actually won't run the query. That's handy if you're working in production and you don't want to really touch production. You can do that. SQL Server will guess at the best estimated plan that it can find or come up with. And so you get an idea. The estimated and the actual should be relatively close, identical. But that's how you turn on the execution plan. So I already have this enabled for this query. So we're going to run this query. We get our values back. We can see up here in the upper right-hand corner, we got 148 rows back. And if we come down here and look at this, I'm going to zoom to fit, see if that worked. It did work. I'm going to zoom in anyways. Oop, I don't want that hover. So we can see this query gave me a key lookup. And so what's happening is the query saying, okay, I'm going to go to that top index, that sales order, non-clustered sales order detail index. It doesn't have all the columns I need. And so it's going to go back to my clustered index and return the columns that I need. And so I'm performing IO hits against my local laptop. Now, extrapolate this out to a much larger system. I've got solid state drive in my laptop. I'm local to my laptop. It's very quick. I'm not going over the network or anything like that. But if you have a larger infrastructure and you have multi-terabyte databases, the performance hit of the key lookup could be pretty big, okay? So we've identified that this query has a key lookup. We know that key lookups are horrible, so we need to go fix it. So I can actually run this query where I'm telling SQL Server, okay, I've identified the index that I need to get fixed. And what I'm going to do to fix that is to use include columns. As I mentioned before, the include columns will actually put the column in the index, but it's not part of the key, right? And so I can use this column. You could drop the index and then recreate it. You can also specify a create by specifying a drop existing. And what SQL Server will do is actually create the new index and then do a name swap. So it actually creates the index offline with a new name. And then when it's done creating that index, it'll actually drop the old one and rename the new one to the old name. Okay. So if we run this query, and we can see that I specified the index, this is my key, and then my include columns are right here. Oops, I can't draw. Order quantity, product ID, and unit price. And I know that I need those columns because if we come back up into our select, these are the columns that the index, this top index, is missing. And so I'm going to add those to the index as an include column. So let's go ahead and run that. It's going to take a second. We can actually see the execution plan of the create statement if you are really curious about the internals of SQL Server. So now we should be able to run this again. Yep, same rows, right? 148. Yep, so the row count's the same. But what's our execution plan look like? So our execution plan has changed, and we no longer have a key lookup. And so we are no longer performing that I/O of having to go back to the clustered index. This one index is satisfying the entire requirements of the query, and we call that a covering index. It covers the requirements of the query completely, and so it doesn't have to go anywhere else. This index satisfies that full value. This is a simple fix to put in place, and again, we fix things pretty drastically by fixing key lookups. It's the first thing that we look for. Okay, and so the next one is an index scan. Same thing, I'm going to be using the AdventureWorks 2017 database. It's really handy. I'm going to actually drop this index just to make sure that it's not there. Now, I still have my show me my actual execution plan turned on. I'm actually going to do one other step here too as well, and that is this set statistics time and I/O on. Setting this value on, SQL Server will actually come back and say, how long did it take to compile? How long did it take to run? How many pages did we read? How many logical pages did we read? How many physical pages did we read? Logical being we read pages in memory, physical meaning that we actually went to the disk and actually got it off of the disk. So we can actually get some more metrics behind it. And that is to just show you that with the right indexing, we actually will retrieve less pages and perform better. So I'm going to run this query and we're going to go look at those values. So we get value back. We get 162 rows back. This is what the set statistics time I/O on and whatnot looks like. So we know that we scanned the sales order detail table. We had 3 scans, which means that we scanned 3 levels. And we have 574 logical reads. So we read 574 8K pages out of memory, right? So logical reads are memory. So that's how many pages we read out of memory for a scan. Because if we look at the execution plan, we see that we indeed have a scan. I knew this because I wrote the demo. But we know that a scan is going to read the entire table or the entire index, and that gets expensive. So we want to fix this. And we want to fix this because I have a predicate. I have a where clause. I'm looking for a specific value. In this case, I'm looking for a specific value of a unit price of $1.34 and whatever the other half is. So I'm looking for a specific value. And that was one of the things that I look for is an index scan where I have a where clause or I have a predicate. I can go fix this. Now, SQL Server is really nice and will actually suggest a index for us. That's the missing index detail that you see there in green. It'll actually say missing impact or missing index. We think that this index will improve the performance of the query by about 93%. That's kind of and really that impact is, I always think of it as percent, but really it's not. It's more of a abstract number that really doesn't have any meaning. The higher the number, the better the value. Let's put it that way. So if the impact is higher, then that index is, according to SQL Server, is going to help. Okay. And so let's do that. And so I have done that. I've actually taken this. You can actually right click and say missing index details. It'll actually open up a new window and actually show you the code to create that index. And so we can go run that and create that index. And you'll also notice that it said, hey, include these values as two. So here's your key, and here are the columns that you need in your include option to fix this scan. It's going to take a few seconds. Don't need the execution plan. So let's go back and run it again. Now, if you remember, when we ran it the first time, 574 was I must have that wrong. Oh, I do have that wrong. There we go. The first time we read 574 pages. So I'm going to run this again. So we see that we now have an index seek. We got rid of the scan, but how many pages did we read, either physically or logically, to now do the seek? So if we come back over here, so we read 3 pages. So 574 down to 3. Again, those pages are 8K. So again, extrapolate this out to a larger environment where you have multi-terabyte databases, or you're doing vast amounts of data volume. This will make a difference. And so this is an easy fix to put into place and get a better performance gain, because my laptop only had to read 3 pages. That makes a difference, especially in larger environments. Okay, how much time do I have? I got 3 minutes, yes, okay. One of the things I've mentioned with finding indexes, I use read-write ratio to see how things are performing. So I have a quick workload. I'm going to start this workload, and all this is doing is calling store procedures out of the AdventureWorks database so that we can see how things are performing. So I have a query, and as I said, SQL Server will tell you a lot of information and metrics about your indexes. So we actually can use this DMV, DM_DB index usage stats, and SQL Server can say, okay, how many reads are we getting? How many writes? So this workload is primarily reading data. And so we can use this query, and I use it all the time, to help identify where indexes aren't being useful. And so we can see, and if I run this again, my values are going to change. So now I'm writing to these 4 tables, these 4 indexes, excuse me. And we can see that my ratio is horrible, especially this person table. I've written to it once, but never read from it. I know that's a really small example, but again, extrapolate that out to a larger set where you're doing large amounts of querying and or data updates. If you have an index that is not being read, but it's being written to all the time, I would look at dropping this index, because it's not serving any purpose other than taking up space and wasting IO, because when you change the data, I have to go update that index. So this query is nice to have, because then I can identify quickly these 4 indexes I might want to go change. So that is a query that I'm happy to share. And SQL Server will tell you this information if you just know where to go look. So that is helpful with help fixing your indexing problems. So those are the 3. I got 1 minute left. This is awesome. That is how we fix those 2 things, the key lookup and the scan, and then how we can identify our read-write ratio. And as you can see, as I run this again, if Hotpin cuts me off, I'm sorry. Yeah, we can see that my ratios are changing. Oh, I don't have the order by. Order by. Yep, so we can see the ratios changing as things read more data or update more data or what have you. Okay, so let's go back over here. Quick demos. The easy things to fix. And that's it. Oh, summary, wrapping up, 1 minute left. Oh, it says 0 minutes. I hope you're all still there. We are? Okay, cool. Sweet. We didn't all disappear. Nice. Quick summary, and I know it's 5 o'clock on a Friday afternoon. So indexes can drastically help performance. I know the examples I showed were small, and I don't have a very large data volume on my laptop, but you can again extrapolate that out to your environment or a bigger environment and see how those could potentially help fix some of your performance problems. It really is a balancing act between finding individual workloads that need indexes and then making sure that we don't over-index and finding the indexes that we're not using. I showed you a query that, again, drop me a note. I'm happy to send that to you. You can run that on your production environments, your non-production environments, find those indexes that aren't helpful and get rid of them in testing and make sure there's nothing strange. I will say the only thing that you might run into is if you have a random query that runs once a year, but it's super important, that one query might use that index. So if you're going to get rid of an index, just make sure you script it out first so you can have it around for safekeeping. Take a look at using Columnstore. Columnstore, again, great with analytical processing, but also starting to make its way into transactional processing where the data is non-volatile. It's not changing. So it might be a good thing to look at for Columnstore. That is all I've got. I took 1 minute over. I feel like I rushed. Drop me a note, send me an email. You got questions, you got SQL Server problems. Marty's asking, do you run maintenance nightly in terms of re-indexing, defragmentation? My DBA answer is going to be, it depends. I have a client that we do run maintenance on certain databases every night. I've actually got a client, they do billing for like nonprofits. And so they're pretty dependent on their financial system. And thankfully, I've got a window where I can actually run maintenance on their database every night. And so that case, I do run maintenance on their database every night. That particular database, like I've got a specific SQL agent job for that database. Other databases, I run index maintenance on the weekends. So like I've got a window on Saturday mornings that runs that. Ed says, I've seen we're adding a query just before querying and removing it after. You're welcome, Marty. I've seen we're adding a query or adding an index just before querying and removing it afterwards. Yes, it's still fast, way faster than not having it all. Now, I will say that adding an index can cause blocking. So before you do adding an index blindly, depending on what version of SQL Server you're at, what edition of SQL Server you're at in terms of online or enterprise or standard, depends which one you're at. If you're on standard and you want to add a new index, it could cause blocking on that table while you're adding the index. So just test everything before you go slap a new index on a very large table. I've seen issues with that. But if you're running enterprise, that you can add that index online, so it'll cause very little blocking. So just make sure you test it. Don't do things in production and say, John said this. I will claim plausible deniability like no tomorrow. And actually, this session's being recorded, so plausible deniability right here. I'm using, you're using DTU. Okay, cool. Yeah, Ed's using Azure SQL Database. I have a couple clients that are using strictly Azure. I got the customer story I showcased was in Azure alone. We're using Elastic Pools for them, but indexing will solve a lot of your problems, most of them. What other questions do you have? We're still here, and we're love it. Yeah, it doesn't have all the features. Yeah, there are some features with Azure SQL Database that aren't there. You can't use like file stream or file table. You can't back up the database or control that, which as DBAs, as a DBA, it took me a while to get used to that concept that I'm not in charge of backing up and restoring that database or ensuring their disaster recovery from that perspective. Yeah, no stretch tables. What else you got? And feel free to unmute and come online. I don't bite. Yeah, not trace flags, but depends on what, Lewis says not having control over trace flags hits him with Azure. A lot of the trace flags have been moved into database scopes configuration. So you can control some of that aspect within the database scope configuration. So if you haven't looked at those yet, you can go look and see if they fit your needs, depending on what you're trying to do. Tom asked, does Columnstore only? So yes. So Tom asks, can you use Columnstore is only good for data that never changes? The answer is it'll be better. But what happens is that as that data changes and morphs, that in the Delta stores, the tuple, I can never pronounce it right. The tuple mover then has to do work to move that data around. And so if you're only changing it minimally, I think you'll be fine. If you're doing a ton of updates to it, then I wouldn't suggest using Columnstore. So I would want to limit the number of updates I'm doing to that data. I just want to be putting new data in, basically. I don't want to be updating it all over the time. Yeah, definitely reach out. Yeah, check out Lewis. I hope I'm saying your name right, Lewis. Definitely check out the database scope configuration. If you're looking for something specific, feel free to drop me a note. And if I am aware to get the behavior that you're looking for, I'll be happy to share it. Definitely, yeah. Go search the meetup, and the SQL Server user group is on Meetup. And I thought we had. All right, cool. We meet at least once a month, I think. It's kind of been iffy with one of the other leaders, actually the two gentlemen that actually run it. I'm kind of behind the scenes a little bit, but he just had a baby not too long ago. Him and his wife had a new child show up, so he's kind of busy with that. But we try to meet once a month. And the SQL Saturday, definitely. I don't know if you're all in Louisville or you're out and about, but we definitely New Albany. Okay. So you have to forgive me. I'm a transplant. I came here from Omaha, Nebraska after 24 years. So I still am not solid on the locations of towns and stuff in terms of New Albany. I know where Elizabethtown is. Oh, across the river. Okay, cool. Thanks for telling me that, because I honestly did not know. Thank you very much, Seth. I appreciate that. I feel like I rushed. If you guys have feedback, if anybody has feedback for me, things I can do better, things I sucked at, feel free to tell me. I'm a big boy. I can handle it. I won't be upset. I promise. You can say it in the chat. You can send me an email, send me a tweet saying, hey, John, you sucked. I'm totally cool with that, because I want to get better as, when I build these presentations. The sunny side of Louisville. I kind of like Louisville. I miss, this is going to sound strange, but I miss the cold of Nebraska, because in Nebraska, you could get like 30 below wind chills and it would be the most crystal clear blue sky. And so I miss that at times. Any other questions? Anything about SQL Server you want to talk about? You got problems at work? I'm happy to give you free consulting.